Alright, so we are looking at lines and planes and vectors and how they're all related to each other. So we have a plane, we call it pi, it's here. We're looking straight down horizontally across it. So it looks like a one-dimensional line, but it's actually a two-dimensional plane that we're looking across. And we have this line L cutting through it. Our plane has a normal vector n, our line has a direction vector d, and we're trying to find the angle that this line makes with the plane. And before I do that, let's label this angle up here, we'll call it phi. And if you're okay with this, let's rearrange some vectors. Here's n, and our direction vector is going off that way. So what is the angle in between the normal and the direction? Well, it's really kind of like we're up here, and that's vertically across from phi, so this angle in here is phi. Okay, so we know that the sine of theta would be the opposite over adjacent in this right triangle, but I don't know the opposite and adjacent sides of this triangle. Using my vector skills, we can look down here, and we know that the cosine of phi not theta is equal to n dot d divided by the magnitude of n times the magnitude of d. Well, how's that related to the angle that I really care about? How is that related to theta up here? Well, let me tell you. The sine of theta is equal to the cosine of phi. That's right triangle trig for us. So what we can actually look at is this and say that this is the sine of theta. And what we need to actually think about is, well, we want to make sure that we're always talking about an acute angle. For standardization's sake, we always want a acute angle for any time we're talking about the angle between two things, whether it's an angle between a line and a plane like here, or if it's the angle between two planes, which we'll see in the next video. And one way that we can deal with that is to take this quantity right here and make sure that it's positive, make sure that we get a first quadrant angle. To do that, we can take the absolute value, and this relationship here, ladies and gentlemen, will find us the angle theta that a line makes with a plane. And all we need to do it, all we need to find this angle is the normal for the plane, which we can find by taking the cross product of the directional vectors in the plane, remember that, and we need the direction vector for the line. That's it. It's a pretty straightforward calculation. It's very similar to just finding the angle between two vectors, and actually that's all it is, guys. It's right here. There you go. On to the next. Okay, so we talked about the angle between a line and a plane, but what about if we have two planes intersecting each other like we have here? We have plane pi 1 in pink and plane pi 2 in white. We want to know, what's the angle in between them? What's this theta right here? We're always talking about the acute angle, remember. So how do we do this? Well, it happens that this angle right there, that's going to be 180 minus theta. These two things are what we call supplementary. Yes, I hope you know that. Now, up here in this quadrilateral, I'm going to use some geometry skills here. How are angles that are opposite each other in a quadrilateral related to each other? Well, they are congruent, or they're supplementary. So this up here is also theta. which means this is theta. And so what's theta? Well, angle theta is really just the angle between the normals. Ha! The angle between two vectors. So to find the angle between two planes, all we have to find is the angle between the normals. And that we know how to do, ladies and gentlemen. We can take the cosine of theta being equal to n1 dot n2, and we're going to divide by the magnitude of n1 times the magnitude of n2. And you know, just like in the previous video, we always want the acute angle. So to take care of that, we are simply going to take the absolute value here, giving us a first quadrant acute angle. And there we go. Angle between two planes is the same as finding the angle between two vectors. What in the world is going on here? All this stuff is the same, and yeah, it is. This formula, this dot product, this angle formula that we have is for angle between vectors, angle between planes, and a little tweak on it gives us the angle between lines, which we just saw how to do.